Hello everyone. In this video, we are going to solve the problem number 1.61 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. We are having two touching bars 1 and 2 which are placed on the inclined plane, which is forming an angle of alpha with the horizontal. Mass of bar 1 is given as m1 and mass of bar 2 is given as m2. There is the friction between the inclined surface and these two masses, and the coefficient of friction between bar 1 and the inclined plane is given as k1, and the coefficient of friction between bar 2 and the inclined plane is given as k2. And we have to find the interaction force of the bars in the process of motion. So these two masses are in contact always. So that's why we will have the only interaction force, that is the normal force between these two bars. In order to find the interaction force, let us first draw the free body diagram of mass m1. So this is mass m1, which is on the inclined plane, and inclined plane is making an angle of alpha. Okay, so we will have the gravitational force in the downward direction, that is m1 into g, and as it is making a contact with the inclined surface, so we will have the normal reaction which is perpendicular to this inclined surface in this direction. This is the normal n1. Okay, and we will have the interaction force, that is the normal force between these two bars. So that is, let us denote it as r, and it is accelerating in this particular direction, so we will have the friction force in this direction, that is equal to k1 into n1, where k1 is the coefficient of friction and n1 is the normal from the inclined plane surface. Okay, so we will have the two direction, one is the normal direction and another will be the tangential direction. So let us take the component of m1g in the normal and the tangential direction. So these are the two components. If this particular angle is alpha, then this angle will be 90 minus alpha and this particular angle will be alpha. So this particular component will be m1g into cos alpha and this component will be m1g into sin alpha. Okay, so let us first balance the forces in the normal direction. As we are not having the acceleration in this particular direction, so we can directly write n1 is equal to m1g cos alpha. Okay, and if we talk about the force equation in the tangential direction, that we can write it as m1g sin alpha plus r minus k1 into n1 is equal to m1 into a, where a is the acceleration. Let us substitute the value of n1 here and we will get m1g sin alpha plus r minus k1 times m1g cos alpha is equal to m1 into a. So this is the first equation we are having. Now let us draw the free body diagram of mass m2. So this is mass m2. So again we will have the gravitational force in this direction, that is m2 into g, and the normal force n2 from the inclined surface, and the coefficient of friction force in this particular direction, that is k2, which is the coefficient of friction into n2, and the normal reaction between the two bars. So let us take the component of m2g in the normal direction and the tangential direction. So similar to the above case, we can write the component as m2g times cos alpha, and in this direction we will have m2g into sin alpha. So let us first balance the forces in the normal direction, that we can write it as n2 is equal to m2g cos alpha, and if we balance the forces in the tangential direction, that we can write it as m2g sin alpha minus r minus k2 into n2 is equal to m2, and the acceleration is a. Let us substitute the value of n2 here, so we will get m2g sin alpha minus r minus k2 times m2g cos alpha is equal to m2 into a. So this is the second equation we are having. Now in the first part of the problem, it is asking to find the interaction force, that is the reaction force between these two bars. Okay, for that we have to eliminate A here. So let us multiply this particular equation with m2 and this particular equation will with m1. So we will get the first equation, we will get it as m1 m2 g sin alpha plus r times m2 minus k1 m1 m2 g cos alpha is equal to m1 m2a. And if we multiply this particular equation with the mass m1, then we can get it as m1 m2g sin alpha minus r times m1 minus k2 times m1 m2 g cos alpha is equal to m1 m2 into a. So let us say this is equation 3 and this is equation 4. Now in order to eliminate this particular terms, we can subtract these two equations, 3 minus 4. These two terms are same, so this will get cancelled, and here we will get r times m1 plus m2 minus k1 m1 m2 g cos alpha plus k2 times m1 m2 g cos alpha is equal to 0. So from here we will get the reaction force as K1 minus K2 into M1 M2 G cos alpha whole divided by M1 plus M2. So this is the reaction force or the interaction force between these two bars we got. Okay. Now in the second part of the problem, it is asking to find the minimum value of the angle alpha at which the bars starts sliding down. Okay, so if we carefully look at here, as it is saying that the bars start sliding down, that means the acceleration is actually 0. Okay, it is at the rest condition, it is just starting to slide down. Okay, for that case we will take the first equation and we will make this acceleration as 0, and we can write it here m1g sin alpha plus r minus k1 m1g cos alpha is equal to m1 into acceleration. And if we write the second equation that we have got, that is m2g sin alpha minus r minus k2 m2g cos alpha minus r minus k2 m2g cos alpha is equal to m2 into a. So this is our first equation and this is our second equation. So from these two equations, first we can eliminate r. Let us add equation 1 and 2. Add equation 1 and 2. So from here we will get m1 plus m2 into g sin alpha minus k1 plus k1 m1 plus k2 m2 into g cos alpha is equal to m1 plus m2 into a. Okay, so this will be equal to 0, as we have stated that acceleration should be equal to 0. For that case we can write it here m1 plus m2 into g sin alpha, that is equal to k1 m1 plus k2 m2 into g cos alpha. Okay, let us take cos alpha to this particular side, then we can write sin alpha divided by cos alpha is equal to k1 m1 plus k2 m2 whole divided by m1 plus m2. So from here we will get tan alpha is equal to k1 m1 plus k2 m2 whole divided by m1 plus m2, and this is the minimum alpha for which this particular mass m1 and m2 will be at rest, or we can say it will just slide down. Okay, so I hope the entire procedure is clear. Thank you.